So in this video, we're going to be introducing the concept of Bicep. Now, if you at the requirements for the AZ 104 exam, you'll see that Bicep is pretty much treated on the same footing as ARM templates. So you do need to understand how to interpret an ARM template or a Bicep file. You need to be able to modify an ARM template or a Bicep file, deploy resources using either, and export your deployment to either. So all the requirements that apply to ARM templates also require to Bicep. So what is Bicep? Well, you can think of Bicep as a domain-specific language for deploying Azure resources. Think of it as an abstraction layer on top of ARM templates. So if you've used or written ARM templates before, then you'll know that there is sometimes a bit of a pain to it. So we can look at an ARM template. We can see all of this set up with the variables and the parameters. When we get into the resources, we have this JSON syntax. Now, this here is not too bad. We got storage accounts and IP addresses and things like that. But you can get into things that have got a fairly good nesting situation going on, like this virtual network definition and others, like this network interface card has IP addresses and subnet IDs and things like that. So this JSON is not necessarily easy to read. Bicep solves this, or attempts to solve this, by being a much simpler, cleaner syntax. And what you do is once you've written this in Bicep, it can compile into an ARM template. So this is why it's called a abstraction. They're not you're not passing the Bicep file directly to Azure. It's being converted into an ARM template, and we're still using the Azure Resource Manager model to deploy the resources. So let's look, this is an example of a template, an ARM template for deploying a virtual machine. And let's look at the equivalent Bicep file. So this is all pretty much the same thing. We've really simplified the variables and the parameters section. So we just basically define something as a parameter, and we can say what's the length and whether this password is a secure field, things like that, give things descriptions. Much easier to read and understand syntax compared to the equivalent syntax in an ARM template. Now you're going to see a lot of stuff that is familiar because really this is just, like I said, it's going to become an ARM template. So if we're defining a storage account, there's no nesting here. You'll see it, the resource command here. And basically we're defining a storage account and we're passing in name, location, SKU, and what kind of storage account. That's going to be very similar to when you define the storage account in this ARM template. We've got type, API version. Again, the Bicep is a bit easier to read, but the information is still there. And we're going to find the same situation. We're looking at defining the IP address, defining the NSG, just the same information, just easier to read, less nesting. Bicep files support all of the features that ARM templates support. So there's no downside. You're not missing out on anything if you write things as a Bicep file instead of as an ARM template. Now, to get started, you've got a few different ways. There is a command line tool for compiling Bicep into ARM template, or for reverse compiling it to get a Bicep file out of an ARM template. But you can also set up your VS Code IDE with a plugin for Bicep, as well as Visual Studio. So if you want to be using your authoring environment as VS Code, that's totally supported right out of the box. So from going forward, what you're going to find is when you're going to try to find quick starts for some of these things, it'll be available in both. You'll have Bicep quick starts as well as ARM template quick starts because Microsoft is now, at this point, it's been several years, Microsoft fully supports both formats. One, easier to read, better for humans, and they all compile into ARM templates. So in this lesson, we're going to write our first Bicep file from scratch. Our goal is to deploy an Azure storage account. Step one is to set up our environment. I have Visual Studio Code here, and I'm going to go into File, Preferences, Extensions, which is Control-Shift-X, and I'm going to look for the Bicep extension. I found it as being the first one when I search for Bicep, and I'm going to click Install. And so this is going to install the official Microsoft Bicep extension. If you already have it installed, make sure it's enabled. This is going to handle all the syntax highlighting and the validation. So step two is we're going to create a Bicep file. And we can do it here within the extension, but we can also say File New. So the file I'm going to create is called storage.bicep. Now in the bottom right here, we can see that the language has been interpreted as Bicep. All right, so our goal is to create a storage account, and we're going to use parameters because we want this to be reusable. We don't want to hard code values. Parameter keyword is param, and we're going to define 3 parameters, one being a location. Now, as soon as I start typing, you'll notice that the IntelliSense is kicked in, and it is suggesting some text, location string equals resource group bracket dot location. I do actually want to accept this, so it is tab in order to accept the suggestion. And the next thing we want to do is param called account name. It is also a string. And this case, we are going to be accepting the letters ST followed by we're going to accept this unique string resource group .id. So this is going to be the name of the storage account, and I can control right arrow or tab in order to accept portions of that. The third parameter will be for the SKU, and you'll see it's already expecting me to look for the SKU, and so I'm going to say SKU name string, and we'll accept the standard LRS as the SKU. Now, again, IntelliSense has kicked in and is now giving me the storage account based on those. Now, this is pretty much exactly what I want: the account name, the location, the SKU, the storage v2, which is general purpose, and we'll accept the default access tier as being hot tier. So I didn't even have to really write much code, but the storage account has been is going to be created in Bicep using this code that's being suggested. Now, the last thing we need to do is output the results. And so there is an output command, and we can see this here, where it's taken in the storage account that's being created, .name, and placing that into an output variable. And that will be output after this Bicep turned into an ARM template is run. So this ends the file. We have a complete, valid infrastructure as code document in just 17 lines of code. And now we can deploy this into the next video. So now we have our storage.bicep file ready, and we're ready to deploy it. Now, you technically can deploy this file using a command line tool like PowerShell or CLI. There's a CLI command such as AZ deployment group create to deploy this file. But there is a faster way to do this inside of Visual Studio Code. So I'm going to right click within Visual Studio Code within the file, and I can see there's a command that says deploy Bicep file, and I'm going to select that. Now the output opens, and I have to give the deployment a name. I'm going to accept the default by hitting enter. Now I've already logged into Azure, and So it shouldn't have an issue with me not being logged in. I am logged in. Now I have to pick the subscription. I'm going to put this into my pay-as-you-go subscription. And it is asking me to create a resource group. I'm going to put this into an existing resource group. And we don't currently have a parameter file. I want to use the default values that have been defined. So I'm going to select none. So now the output window will start to contain details on the deployment. The output window says the deployment has started and we're waiting for it to complete. And now it says deployment succeeded. You see it took about 30 seconds. So to validate this, I can go into the Azure portal. I can go into the resource group where I deployed this. And I can see that a storage account ST with a random set of letters and numbers has been created, and that this was the one that we just deployed using Bicep. We can even go back to the resource group level under deployments. And we can see that it succeeded with the deployment using the name that we provided during the deployment. So this proves that Bicep is a transpiler. It took my clean Bicep code, turned it into a standard ARM template, and submitted that to the Azure Resource Manager for deployment. We can see this as an ARM template, the code that I wrote as a Bicep. So this was a successful deployment of our small example of our Bicep file. So the process from going from a Bicep file to an ARM template is called compiling, obviously part of the deployment process. But if you want to go in reverse, if you want to take an ARM template and turn it into a Bicep file, that's called decompiling. And believe it or not, it can be done because, like I said before, all functions available within ARM templates are generally available within Bicep, even preview functions within Azure. Now, there is a decompile command at the Azure CLI, so AZ space Bicep space decompile, pass in the JSON file, and you'll end up with a Bicep file. We also have the ability within VS Code to do the same thing in a much easier fashion. So VS Code, as we know, we have the Bicep extension, and we have a number of commands. And if we go to the top bar, the command bar, and start typing Bicep, we're going to see a list of commands. Here's an ARM template that we used in a prior video that is quite complex. It's got 3 virtual machines on a virtual network, 3 network interface cards, and an NSG. So this is the setup to some load balancers we were going to create and application gateways. So this setup contains 3 VMs. So let's convert that into a Bicep file. Now, like I said, there's a couple ways we can do this. We can go up to the search with a greater than sign, and we can see decompile into Bicep as one of the options. There's also a shortcut. If you right-click on the JSON file name, scroll to the bottom, decompile into Bicep is one of the options. Now, it's quite fast. It's done very quickly. Decompilation complete. I have a Bicep file now in my local file directory, and we can also see it here in VS Code. So we can look at the various parameters that have been created and the naming of it. We can look at the resources. Remember, we have 1 virtual network, 3 network interface cards, 3 virtual machines. Here's the network security group that contains the security settings. There's the virtual network. And pretty much we're going to have all of the resources properly created in Bicep format. So going from ARM templates to Bicep, I think Visual Studio Code is the simplest way. You can certainly use the Azure CLI to do it as well. It's pretty much going to work because, as Microsoft has said, almost all functions in ARM templates can be done in Bicep, even preview and general availability features of Azure, so Bicep format. So going from ARM templates to Bicep, I think Visual Studio Code is the simplest way. You can certainly use the Azure CLI to do it as well. It's pretty much going to work because, as Microsoft has said, almost all functions in ARM templates can be done in Bicep, even preview and general availability features of Azure. So it's fairly mappable one-to-one in terms of what ARM templates can do and what Bicep can do at this point. And that's how you decompile ARM template into a Bicep file.